Hello and welcome to Engineers Got Blued. In this presentation, I'm going to show you a solution for this problem, and we are asked to solve for Vx, or it could be Vo. Either of the two notations, you may denote your answer. And part of the solution is to determine the power supplied by Vx or Vo, and take note that it is a dependent source. So our orientation in dealing with power supplied by a certain source, okay, power supplied must be expressed in negative. That would be our orientation or sign convention of a power being supplied. So my point is, if you solve for the power of that element, you have to express that in negative p. Okay? So let's begin with the solution. So it's easier to analyze this using mesh analysis. So we have here I1, I2, I3, and I4. And by inspection, we have here I2 is equal to negative 2 angle 0, or it is 2 angle times 1/8 amperes. And we have here I3 also, which is equal to 4 angle 0 ampere. So take note that the values for the current and voltages here are not in RMS, but we are only asked to solve for the power supplied, so it doesn't matter if you're going to denote the solution in RMS value. Okay, so again, there's no need to solve for the RMS value since it is not asked that we are going to solve for the complex power, but generally we are asked to solve for the power only. So again, if in the problem, if it doesn't specify a complex power, then therefore there's no need to determine the RMS values of the voltage and current. Okay, so since I2 and I3 are already known, so let's only solve for I1 and I4. So at I1, perform KVL. We have 6 plus I1 times 1 minus J minus I3 times negative J1 equals 0. So I1 is equal to 5.099 angle negative 101.31 amperes. And then KVL at I4, we have I4 times 2 minus I2 times 1 minus I3 times 1 plus Vx equals 0, and so we have Vx equals I1 times I1, and so finally Vx is equal to 5.099 angle negative 101.31 volts. Be aware that Vx or VO is a source that is dependent to the voltage drop of the 1 ohm resistor, and since we already solved for I1, therefore we could solve for Vx, and so Vx is equal to 1 ohm times I1, which is equal to 5.099 angle negative 101.31. And now to complete this KVL equation, the result would be I4 is equal to 2.915 angle 59.036 volts. Okay, so let's solve now for the power, which is equal to 1/2 times V I conjugate. And since it is a source, a power supplied by a source, so we have to denote this as negative. I am exaggerating the negative sign, so we have equal to negative 1/2 times the voltage, which is equal to 5.099 angle negative 101.31 times current 2.915 angle 59.036 conjugate, and this would result to, we have negative 7 minus J 2.5 VA, where 7 is the real number, the real power. We have 7 watts, and the complex power conjugate, the imaginary part, which is the reactive power, in bar we have 2.5 bar. So this is the answer. The power supplied from the source VO, that is equal to minus 7 watts minus J 2.5 var, or you may denote your answer as P, the power supplied, equals negative 7 minus J 2.5 volt amps.